Today we are going to perform simple linear regression. So welcome to my YouTube channel. We will see how we can perform that. So thank you for joining and thank you for watching this video. So here I have two set which is called train and test set. So here you can see here my train set has some information which contain x and y, and my test set has some information which is also you can see here. So also I will put the shape of train set and test set. So you can see here dot shape. You can see here in my train set we have 700 rows, but in my test set we have 300 rows. Means total in my data set we have 1000 row, which 700 contain in the training part and 300 rows we use for the testing part. So we perform the simple linear regression. Before that we will check that is there any null values present in my data set or not. So here train dot is a it's a function. Also I am doing here the sum, so it will give me like okay any null values is present in my data set or not. If that present, then this will give me the 1 or 2 or something like that. So here we can check for test as well. Is a it's a function, so I am just using parenthesis and then sum. So there is like 0 0 0 0. There is no na value which are present in my data set. So we are good to perform the linear regression operation. To performing the linear regression operation, first of all we need to import sklearn. So we can say import from sklearn dot so for the linear regression, sklearn provide one function which is called linear regression. So it's linear regression function present on the linear model. So we can import that linear model, then we can say import linear regression. So we can see hit enter. So here the linear regression is successfully we imported. Now we can create one regression instance. So you can see here regression is equal to linear. It's a class, so I'm just initializing the instance with the blank one. So instance is initialization successfully. So we need to pass train data. So my linear regression model will train itself and give me the coefficient and intercept. So for that we use the fit method. So here regression dot fit, and I am giving it like train of x and comma train of y. Sorry for that. So here you can see here once I hit enter, you can say okay, here is the error. Expect two-dimensional containers but got class has the series parameter and something like that. This error we got. So I know how can we solve this. So let's fix this error. So for fixing this, we pass the one-dimensional array to the fit method, but fit method only accept the two-dimensional array as a part of the x and y input. So for passing the two-dimensional array or converting the two-dimensional array, we just use here extra square braces. So here you can see here I'm just implementing the extra square braces, and you can see here my regression model is train itself using my training data. So now we can check that what is the coefficient and what is the intercept value. So here I am just using regression dot coefficient. So my coefficient is like 0.4 and my regression dot intercept is my 47. So what is the equation of linear regression? Let me put it here. Y is equal to mx plus c. So my c value is the coefficient which is like 0.04 and my intercept is the m. So it's a 47.4 and my x is here and y is here. So I am predicting the y based on the x values. So here I just put the equation of the line for the really simple linear regression. So now our model is 10. We got the values of coefficient and all. So let's test it or let's predict something which present in our test data set. So for predicting the test data set or predicting the y using from the taking the x, so how we can do that? We just use a regression dot predict method. So here I am just passing the test of y. sorry, test of x. So you can see here my model is predicting. So again we got the same error. To fix this error, to predict accept only 2D array, so we just add the extra parenthesis here. So you can see here my all the models or all the predictions, my linear regression model give me the prediction which accept the x values and give me the prediction of the y value. So this is the all the y values. So we can say here y underscore predict equal to and this one. So I'm just assigning these things, and let's say actually I have like original y as well for the test data set and the predicted y as well. So we need to check that what is the accuracy of this, means is my model is the good way or not, is this prediction is okay or not, or prediction is correct or not. So for checking that, what we can do, we need to use the mean square error method. So here you can see here from the SQL documentation, official documentation, you can see here mean square error. So here mean square error, which is taking two argument, which is like y true and y predict, and based on that it will give us like some number, which is we can see like this is the error in my function, and this means which is how much my y prediction or how much my prediction value is close to my actual value. So for doing that, we just have to import from sklearn dot, what is that class is for mean metrics import mean absolute error. So here I just imported that, then I give mean absolute error y test of y, this is my actual true y, and we can say here predicted y. So y underscore predict. So you can see here it give me like 23. So 23 is my mean absolute error, means between from my y true to my y predict, the gap between this is 23. So that's why my not much accurate my predictions are, but it's close to the actual one. So but because this is the sample data and this is the test data, so that's why it's give me some accuracy, but we can fix that accuracy in the future videos. I will show you how we can increase or decrease this error so we can get actual predictions. So thank you so much for this video. This is pretty much from the linear regression side. This is the simple example, test example, how you can predict something based on the linear regression. So you can copy and paste the code and run it to yourself, try it to yourself. Thank you so much.